Have you ever wondered how that happens? You click a link, and in a split second, a video from the other side of the world just appears on your screen. Well, in this explainer, we're going to pull back the curtain on how that internet magic really works. And hey, by the end, you'll not only get the core concepts of IP addresses and routing, but you'll also be totally ready to ace those exam questions.
So let's just start with that one big question. You click on a video, a web page, anything at all, and bam, it's right there. But how? How does the internet find your one specific computer out of the billions and billions of devices connected all over the planet?
Okay, here's how we're going to break it all down. First up, we'll look at the internet's address system. Then we'll dive into how data finds its way around. Think of it as the internet's GPS. After that, we'll talk about the difference between local and global delivery. And finally, we'll wrap it all up with an exam cram to make sure you've got the key takeaways locked in.
Right, let's jump straight into part one. This is all about how every single device that goes online gets its very own unique home address.
So the backbone of this entire system is something called the IP address. Now, IP just stands for Internet Protocol, which is really just a fancy term for the rules of the internet. The easiest way to think of it is this. An IP address is a totally unique home address for your computer, your phone, whatever device you're using. It's a thing that tells the internet, hey, send that cat video right here.
Now, deep down, computers only speak in ones and zeros, right? So an IP address is really just a long string of 32 of them. But can you imagine trying to remember that? Yeah, me neither. So to make it easy for us humans, we just break it down into 4 simple numbers separated by dots. Something like 12.34.56.78. So much easier to deal with.
But here's the problem. What if we just gave every device a totally random number? Well, imagine trying to deliver mail in a city with no street names and no zip codes. It would be total chaos. That's exactly the problem the internet's traffic controllers, we call them routers, would have. Each one would need a phone book for the entire internet with billions of entries, and it would be impossibly slow.
And this image right here just drives that point home. It shows complete chaos. If every address is just random, a router is like a tourist dropped in the middle of a foreign city with no map. It has absolutely no clue which direction to send anything. A system like this, it just can't work for an internet as massive as ours.
So the solution is actually pretty brilliant, and it's super simple. We basically just copy the postal service. We take that IP address and we split it into 2 parts, a network part and a host part. Just think of the network part as the zip code. It gets the data to the right general neighborhood. The host part? That's the specific house number, making sure it gets to the right front door.
And this is the key idea, right here. A router on the other side of the world doesn't need to know your exact street address. It just needs to know the zip code to send the package to. Once your data gets to your local area, the local routers take over and figure out which house it belongs to. This 2-part system is what makes the whole internet possible.
Okay, on to part 2. Now we know every device has a smart 2-part address. So the next question is, how does a piece of data actually figure out the best way to get there?
And that's our next big question, isn't it? Your computer sends out a little chunk of data, we call it a packet, and it has a destination IP address on it. So what happens next? How does that tiny packet navigate the huge, tangled web of the internet?
Well, the answer is something called a routing table. You can think of it like a router's own personal GPS or map. The cool thing is, it doesn't need to know every single address in the world. Nope, it just has directions for all the major zip codes. It tells the router, hey, if you need to get to this neighborhood, you got to take that highway.
This picture shows that process perfectly. A data packet shows up, the router takes a quick look at the destination's zip code, that's the network part of the address, it checks its routing table, finds the right match, and boom, it sends the packet out the correct exit, one step closer to its final destination.
Okay, for part 3, let's talk about a really important difference. Think about it. There's a big difference between your local mail carrier, who knows every single street in your town, and the National Postal Service that just moves mail between big cities. The internet, it works pretty much the same way.
So we have 2 types of routing, intra-domain and inter-domain. Intra-domain is like routing inside a single network, say your university's campus network. Inter-domain is the cross-country road trip, moving data between huge networks, like from your internet provider over to Google's network.
Inside one network, for that intra-domain routing, all the routers are buddies. They're constantly chatting with each other, basically yelling, hey, I'm router A, and I'm connected to these 3 networks over here. By sharing all this information,
Every single router builds an identical, perfect map of the local neighborhood. It's an amazing system for finding the fastest local path.
That's great for local stuff. But it brings us to the really big question. How do these giant, separate, and sometimes even competing companies, like AT&T, Comcast, Google, how do they all agree to pass information to each other across the entire globe?
The secret is a special protocol, a special language called BGP. That stands for Border Gateway Protocol. This is what we use for inter-domain routing. Think of it like a global treaty for mail. It's the set of rules that lets the U.S. Postal Service and the German Postal Service work together to get your package delivered. Honestly, BGP is the unsung hero that holds the entire global internet together.
All right, let's wrap this all up with a quick exam cram. If you're studying for a test, this is the part where you're going to want to really pay attention. This is what you absolutely need to know.
Okay, revision time. Here are the key concepts. An IP address, it's a unique address for any device online. Hierarchical addressing, that's the genius network/host split, to zip code and house number idea. Routing, that's just the process of finding the best path using a routing table. And finally, you've got intra-domain routing for local trips and inter-domain routing for those long-haul journeys.
Look, if you're short on time, just focus on these 3 things. Seriously, burn them into your brain. First, what an IP address is, and that 4-number format we use. Second, why the network versus host split is so critical. It's all about making the internet work at a global scale. And third, make sure you can clearly explain the difference between routing inside a network and routing between networks. And hey, if you really want to test yourself, just pause here for a second and try to answer these questions out loud. If you can explain these concepts clearly, trust me, you are in great shape for your exam.
So the next time you load a web page or watch a video, just take a second to think about the incredible journey that data is taking, from your device's unique address to a local router's map, hopping across oceans and continents using BGP, and then all the way back to you, all in the blink of an eye. It's an unbelievably complex system, but now you know the secrets behind the magic.